Hi everyone, and here are a few more examples with the use of the quotient rule, and then we're going to go back and do some more examples with the product rule. And really these are the foundation rules for derivatives, so later on we're going to add a few more things like derivatives of trigonometric functions or logarithmic exponential, but all those other additions really rely on these foundational rules. So that's why we need to make sure that everybody gets this and becomes fluent at these. So let's take a look at number 10. G of x equals 5x plus 2 divided by 2x minus 1. We're asked to find the derivative of that function. So again, we notice it's in the form of a fraction with x variable on the top and the bottom. We're going to go with the quotient rule. So one thing we learned in the previous segment, so the rule is, let's say if you have something of the form f over g, its derivative with respect to x is, you take the lower times the derivative higher minus higher times derivative lower, and everything is divided by denominator squared. So here the lower one is 2x minus 1 times the derivative higher, which is 5, minus the higher one, 5x plus 2, times the derivative of the lower, 2, all over denominator squared. Again, it's important to remember that with the quotient rule, it has to go in the numerator in the specific order. Like you couldn't put this one first instead of that one because there's a minus in the middle, right? So that otherwise you'll get -1 times the correct answer if you did that reversal. So very important to have that one set up correctly. Let's distribute. So we have 5 times 2x, which is 10x, minus 5 times 1, minus 2 times 5x, so minus 10x, and minus 2 times 2, so that's minus 4, everything over the same denominator, 2x minus 1 squared. And if you simplify the top, notice 10x minus 10x, you're going to cancel. -5 minus 4 is -9 over 2x minus 1 quantity squared. Oh, let's take a look. This is a little bit more unusual. For example, derivative of ax plus b divided by cx plus d. Now, it may look like, oh, there's so many variables, but notice because we have d over dx, the only variable is really the x. The other ones can be treated as a constant. A, b, c, and d are all constants with respect to x. So we're going to apply the same rule, the quotient rule, which requires that we have the denominator squared be placed in the denominator here. Okay, so for the numerator, we're going to need the lower times the derivative of the higher. The lower is cx plus d times derivative of the higher. Okay, ax, so think of a as like a 5, right? If you have 5x, what's the derivative? 5, right? So here it's going to be a is our derivative. And b is just a number. With respect to x, its derivative is 0. Minus, take the higher one exactly as it is, ax plus b, and multiply it with the derivative of the bottom, which is c. And all we have to do now is simplify the numerator. The bottom will stay as cx plus d squared. So on the top we have a times c times x plus ad minus axc, so that's a times c times x, so minus acx, and then the minus sign, so negative b times c, so negative bc. And notice that the first and the third terms, they cancel, so we're going to be left with ad minus bc all over cx plus d quantity squared at the bottom. Okay, and one more example in the quotient rule. This one again is a little bit unusual. We did something similar to this with the product rule. The thing is, we do not know what f of x is in this definition of g of x. G of x is defined as 2x plus 1 over f of x. We don't know what f of x is. But regardless of that, we can still determine the derivative of g of x based on the given information, because they told us that f of 3 is -2, f prime of 3 is 4, and they want to know what is g prime of 3. So what do you think we have to figure out first? If you said g prime of x You are absolutely correct. So let's figure out g prime of x using the quotient rule, and then everywhere we see an x, we can substitute a 3. Okay, so let's start with g prime of x equals, so here we're going to take the lower one, which is f of x, times derivative of the higher, which is 2, minus the higher one, times the derivative of the lower, which is f prime, all over denominator, which is f of x squared. And to find g prime of 3, I'm going to plug in a 3 for every x. So f of 3 times 2 minus, okay, plug in a 3 in here. 2 times 3 is 6, plus 1 is 7. So minus 7 times f prime of 3, all over in the denominator, f of 3 quantity square. And I'm going to plug the values of f of 3 and f prime of 3. So given that f of 3 is negative 2, so we're going to have negative 2 times 2 is our first term, so negative 4, minus 7 times f prime of 3, 7 times 4, everything over f of 3 squared, that's negative 2 quantity squared. Okay, so simplifying that a little bit. So here we're going to have 4 times, so negative 28. I have minus 4 minus 20, so that's negative 32 over positive 4. So the answer is negative 8. So what does that represent? It represents, for the function g of x, it represents its rate of change at the point 3. It also represents the slope of the tangent line to the function g of x at the point 3. So a few mixed examples now, and remembering from the last section when we learned how to write the equation of the tangent line at a given point, we're going to do the same thing, but now we have shortcut rules, and now we also know about product and quotient rules. So here, given f of x equals x minus 4 times 2x plus 7, we are asked to determine the equation of the tangent line at the point 2. So to determine the equation of the tangent line, the first thing we have to know is, let's call it slope of the tangent line m. And slope of the tangent line is the same as the derivative, right? Slope of the tangent line. Okay, so at the point 2, so we're going to need to find f prime of 2 to get the slope of the tangent line. And once we have that, we can also figure out the y-coordinate at the point 2 by finding f of 2, right? That'll be the y-coordinate. And from there, we can use the equation from algebra. Y minus y sub 1 equals m times x minus x sub 1 to get the equation of the tangent line. And I know some of you also like to use this one instead. If you know m, if you can figure out b, that's another way to get the equation of the tangent line. Either one would work. So let's begin by finding slope. That's f prime of 2. To find f prime of 2, I'm going to use the product rule. So first, f prime of x. So the first quantity, x minus 4, times the derivative of the second, which is 2, plus the second quantity times derivative of the first, which is 1. And now let's simplify. 2x minus 8, and 1 times anything is itself, 2x plus 7, and let's add the two x's together. We have 4x, and the negative 8 plus 7 is minus 1. Remember, we need to know the slope at the point 2. So f prime of 2, plugging in 2 here for x, 8 minus 1, we're going to get 7. Okay, so now we have our answer. Slope is equal to 7. Okay, next let's find f of 2 to get the y-coordinate. So to get f of 2, I need to plug directly into the given equation, where we have 2 minus 4 times 2 times 2 plus 7. So 2 minus 4 is negative 2, and here we have 4 plus 7 is 11. So f of 2, or the y value, is going to be negative 22. So it looks like what we're given is slope is equal to 7, and the point that this line, the tangent line, goes through is the x value 2 and the y value of negative 22. So we're looking for a line with those properties, with a slope of 7 going through 2 comma negative 22. I think out of habit, I always like to use this one, y minus y sub 1. So I'm going to proceed with that to get the equation of the tangent line. So here we have y minus negative 22 equals the slope 7 times x minus the x coordinate, x minus 2. So let's simplify. Y plus 22 equals 7x minus 14. And in the last step, let's subtract 22 from both sides. So y equals 7x minus 14 minus 22. And here we get y equals 7x minus 36. And something you can do at this point is you can go to desmos.com or you can go to graphing calculator. And for y sub 1, you can enter your f of x, which is given up there. And for y sub 2, you can enter your f prime of x, which we found over here. Rather, it's not really f prime of x, but it's the equation of the tangent line. So you can go ahead and enter the equation of the tangent line, which is 7x minus 36. And you can notice that, and you can try to zoom in around the point x equals to 2, and note that the two are indeed tangent to one another. And if not, that means perhaps there's a mistake somewhere. We should go back and check our results. But that's a good way to check your solutions. Okay, let's see what other types of questions we have here. Okay, another one of the similar one we did earlier with an f of x in it instead of knowing the full function. We can take a look at that. Another one about finding the equation of the tangent line. I think I'm going to give you the answer for that one. I think you're going to be able to do it. And those are the last two problems. So let's take a look at number 15. So again, we've done something like this. This will be a great example for you to try and then come back to check your answers. We want to know g prime of 4. By know you know the drill, right? What is the first thing you would have to find? G prime of x, right? So exactly. So let's find g prime of x. And which rule are we going to have to use? The product rule, right? And it also helps to remember, what do we know about the derivative of the square root of x function? And remember, square root of x is the same as x to the 1/2. And if you bring the power down and subtract 1 from the power, you get 1/2 x to the negative 1/2, which is the same as 1 over 2 times the square root of x. Because x to the negative 1/2 come into the denominator is x to the 1/2 in the denominator. And if you remember when we first saw this, I said this is going to come up a lot. Some of you may already remember that the derivative of square root of x is 1 over 2 root x. If you don't remember it, I would say try to commit that to memory because it will save you time. Okay, so now we're going to use the product rule on the given function, on this function, root x times f of x. So the first quantity, root x times the derivative of the second, f prime, plus f of x times the derivative of square root of x, which is 1 over 2 root x. Now I want to know what happens at the point 4. So everywhere I see an x, I'm going to plug in a 4. I'll simplify it later. Square root of 4 times f prime of 4 plus f of 4 times 1 over 2 root x. Oops, instead of x, I better put a 4 in there as well. Okay, now let's simplify. Square root of 4 is 2. F prime of 4, that was given, right? 6 times 6 plus f of 4, also given as negative 3. Times 1 over 2 root x. Okay, in this case, 2 times root 4, square root of 4 is 2. Outside there's another 2, and 2 times 2 is 4. So it'll be times 1 over 4. So simplifying this a little bit, 12 minus 3 over 4. And we can get common denominators, multiply the first top and bottom by 4. So now you have 4 over 4 times 12 minus 3 over 4. So they both have a denominator of 4. I can combine the numerators. 4 times 12 is 48 minus 3. So we're getting 45 over 4 as our final answer. Okay, and for the last question, it's going to be similar to one that we did earlier. I'll have you do that one. Again, find an equation of the tangent line. Remember, you need to find the slope by taking the derivative, the y-coordinate by plugging in into the original equation, and then use your equation of a line formula to obtain the equation of the tangent line. So let me find the answer and I'll give it to you for you to check for later. So for this one, again, you're going to find the slope by finding f prime of -1. You're going to find the y-coordinate by plugging -1 into f of x, and then use this equation to finish the problem. And so that you can check later on, your answer should be y equals 4x plus 2. And next, we're going to look at derivatives involving trigonometric functions.